moving on to the last section of chapter 10, we are going to look at applications in real life, so modeling questions, as you've seen in other chapters. Okay, so over here we've got example 7. We've got an equation, 15,000 times 0.85 to the power of x minus 1,000 sine x. You need to be careful to make sure that you are in radians when you're dealing with this question. And I think I am. Check my glasses. Yeah, I'm in radians. Perfect. Okay, so we're going to, in part A, use this model to find the value to the nearest £100 of the car 10 years after purchase. So if x represents the time, x years, so x is equal to 10, we're going to sub it into the equation. So it's going to be 15,000 times 0.85 to the power of 10 minus 1,000 sine 10. Okay, so it's going to be 15,000 times 0.85 to the power of ounce minus 1,000 sine ounce. Okay, so that gives me the answer of 3497, which we've been asked to round it to the nearest 100, gives me 3,500 years. That doesn't make sense. Not 3,500 pounds. I forgot what the question was all about. Yeah, absolutely. So that's how much it costs. Not years. That would be a very old car. Anyway, and now for part B, we are asked to show that f of x has a root between 1.9 and 20. No, actually 19 and 20. So that tells you that the price dips from positive to negative between year 19 and 20. Let's see whether that's the case. So if you put 19 in, I am not going to, I've already shown one substitution. I'm just going to use the calculator. Put 19 equals, scroll up, let's sub it in. That gives me 534. So 534 pounds. And then the 20, minus 331.55, that's clearly less than 0. This is greater than 0. So always write the comment. So continuous function and change of sign or sign change, therefore root between 19 and 20, or you could say belongs to interval between 19 and 20. Okay, so for part C, we've been asked to differentiate this, so that's a nice bit of algebra here. So we're going to do 15,000, remember, a to the power of x, differentiate to a to the power of x, ln a. So over here we'll have 15,000 times 0.85 to the power of x times ln 0.85 minus 1,000 sine goes to cos. Part D, we are going to use 19.5 and are using the Newton-Raphson method to find the second approximation. So we are told actually to use it only once and give the answer to one decimal place. So we're going to use xn plus 1 is equal to xn minus On the top, we've got the function, so f of xn, so 15,000 times 0.85 to the power of xn minus 1,000 sine xn over the derivative, which is 15,000 0.85 to the power of xn multiplied by ln 0.85 minus 1,000 cos xn. So starting with x0 equal to 19.5, x1 is equal to all of that with x equal to 19.5. Okay, so just save myself writing all of that. You can write it with 19.5 if you want to. I'm just going to again use the ans key because it's easier to type in rather than 19.5. I only need to do it once, so you could use 19.5. 0.85 to the power of ans. Okay, and then you've got minus 1,000 sine ans. Let's go to the bottom of the fraction, so it's 15,000 times 0.85 to the power of ans. I haven't surrounded it with brackets, but it remembers bit mass, so that's fine. Multiplied by ln 0.85. Close brackets, so to check that you have closed the brackets, and then finish there. Minus 1,000 cos ans. Oh, error. What didn't like? I think 1,000. Maybe put times here. Not sure why it doesn't make it. Okay, so that's okay. I didn't need the times, but it's closing those brackets was important. So let's put 19.5 equals curl up. Okay, so that gives me the answer of 19.5279. 751. Just double check whether you're doing it right. It looks like, look, it stays the same. It's so powerful, this method. It's just after the second click, look, try it again. Okay, so that's the first approximation, which we don't have to sub it in. Press it once. Oh no, scroll it to the equation. Okay, there you go. It becomes 19.5279. Press it again, and then you've got 19.52818589, and that was x2. You're not asked to do it twice, but I just want to show you. x3 will be 19.52818592. So they started changing 1, 2, 3, 4, 5, 6, 7th decimal place, and then it will become the same. So there you go. It's exactly the same. So with a couple of clicks, you get a really accurate answer to correct to. If you could see they agree to 3 decimal places. It's 19.528 after the second click. Okay, so next one, criticize this model with respect to the value of the car as it gets older. So obviously we are referring to the fact that after 19.5 years, the value of the car becomes negative. So clearly obtaining using, this model for older cars is not really good. So because in reality you won't get a negative value, so we cannot have a negative value of a car, which would happen for 20 or older, 20 years old or older cars. Okay, so this is the end of this chapter. You can go and have a read through questions on exercise 10D, and make sure you don't skip any. Really important to do those modeling questions, because they are really difficult to find, because that's a new content. There's only 5 questions in the exercise, and they follow it with the mixed exercise for chapter 10. Enjoy.